just to see what is the environment there. Okay, we have a certain orbit, 400 kilometer altitude, sometimes a little bit changing, quite a speedy platform. It has to be that way, in order to cruise in 90 minutes around, and to keep the orbit. The inclination is there, you can hardly change it, and we cover a large area of the Earth, and even a larger area of the Earth population, and to look down from the space. What we can measure, what we can observe there, is a lot of things. Certainly cosmic rays, solar wind, and charged particles, spacegravity. And there is certainly a little more in detail to be observed there. But also the ISS feature is a very special one. Astronauts can and must go outside to deploy the payloads, partially to service them and or to retrieve and bring them even down to Earth. Also no satellite can do so. And ISS provides power, telemetry, cooling and whatever resources, which is quite important for a lot of payload in order to make them operating up there. Okay, now just to get concrete, where are we? In terms of accommodation size, and at least once the space station is fully deployed, and I believe we are very close to this stage, we see the truss is largely complete, and you will have the truss, the US sides on the truss on the starboard and on the port side, where payloads can be deployed, certainly, which also serves partly as on-orbit spares warehouse outside for unpressurized spares. Then also a very important feature is certainly the transportation to the ISS, also in terms of external payloads, which are specific ones. They usually go unpressurized. You see here on the left picture the two ESA payloads riding on the 1E launch, UTEP and Solar, in the shuttle cargo bay on an unpressurized carrier up there in a shuttle cargo bay, in front of the Columbus lab. Certainly also Soyuz and Progress can transport, but only small external payloads which have to be brought outside from the pressurized area. Then ATV, the same. There is not a specific unpressurized section, but then comes HTV on the right-hand side, which also features unpressurized payload transportation as a very unique feature. Now, being a bit more concrete, and I decided not to mix up all kinds of payloads in various segments, but to go a little bit chronologically, and I believe in all fairness we have to say the Russian ISS segment was first in terms of being there, available for attaching external payloads. This was Matryoshka, which was for quite a long period outside. You see it just here on the left upper during the retrieval by the astronaut during an EVA. Then the global time transmission system, which is where we have even the Mark II outside for the time being operating there. And you see them all in the middle part of the Russian segment module. And also even some other payloads there. And the Exposed, which is an exobiology facility, flying up by the end of this year. Then more truly Russian payloads, partially being up there or coming up very soon, really is biorisk. This is all very much in the medical area, which looks as alteration of organic species during long-term exposure, and a lot of space environment measurements, plasma measurements, neutron detectors and all that kind of things, and also particle, the platon being kind of debris detector. You see the big plates up there, and they all are deployed at various locations along the Russian ISS segment, all coming up in the very near term before 2010. Here a very concrete one, which was also on the previous configuration overview. The Bohr telescope of neutron really is measuring fast neutrons and other particle stuff on the ISS outside. There's a part of the payload being outside, the detector, and some electronics inside. And then, okay, if you allow me, also still in chronology, I'm most happy to show here the Columbus with also its external payload facility on the right-hand side, on the so-called back porch. with the two payloads outside there, UTEF and Solar. Solar being the one pointing out of the picture, the UTEF laterally, which are there for deployed since the 1E flight for 1.5 and 2 years respectively, and then they will be retrieved. On the left upper you see the US astronaut being supported by a piece of robotics, again below and at his feet, deploying the Solar payload from the shuttle cargo bay, from the carrier, onto the location where it's staying then for 2 years. And there we also see the interaction between robotics, humans, and also the science aspects. Just to give you a flavor of the multidisciplinarity of the UTEF platform and instruments, you can see here, it's more than technology only, because also, for example, it comprises astrobiology or exobiology. There's the expose experiments, which are 5 in total, but it's also looking at material degradation, radiation measurements, the debris, the micrometeorites impacts, and again also mentioned the pipette, atomic oxygen around the station. Then also a very interesting experiment, similar to the UTEF to a certain extent, is NASA's MISSI 6. You see, it's not by chance, number 6, because it's based on a series of such experiments. But this is the first one, which has been also brought up during the 1JA flight, 3-4 months ago, and sitting also on the Columbus external payload facility for more than a year. There are huge trays which are being populated by enormous numbers of samples, you can see there, and they're also really exposed to open space and then being retrieved and brought back to Earth for detailed analysis. And then the next big platform coming up there is certainly the ones in conjunction with the Kibo module, where we just see here the lab deployment some 4 weeks ago. Very successful, very straightforward, and where this external platform will follow in less than a year from now on the 2JA flight. You see here, also with some of the payloads, some of them will fly up on the same flight, and they are being deployed there really laterally, or on the side ports, which are for the, in relative terms, smaller payloads. And you see a lot of accommodation sites, 10 of the 5 left and 5 rights, and then 3 for the huge ones at the very end of the very platform, plus some robotics on the Japanese side, plus an airlock, which also is, gives the interaction between the inside and the outside. And there you just see JAXA's first set of external payload for this very facility, which is the space environment data acquisition, to monitor all kind of particles, neutron, plasma, atomic oxygen, heavy ion. So you see it's a multi-instrument assembly. Then the all-sky X-ray image, the MAXI, and to observe X-ray bursts, and then the SMILES, which is really a submillimeter sensor assembly for sounding the atmosphere. And then big ones to come. Okay, we have to see if they can materialize. The Extreme Universe Space Observatory, which is really a very international one, also European folks are involved there. It's certainly, as you see, it's a huge beast. These greenish ones, which looks a little bit inclined down there. And the other one is the calorimetric electron telescope, the CALE, which searches for the origin of cosmic ray and dark matter. Okay, then also coming to NASA, I think, unfortunately, there I think it's a bit lean on the NASA side. Also, ESA developed some time ago this hexapod, which is a precision pointing device. It's in storage at ESA, and it could be also deployed there. But I think for the time being, there are these 2 concrete payloads there. The HREP, a hyperspectral imager for remote atmospheric and ionospheric detection system as a kind of experiment payload.